Welcome to doassignment-ca. Here is the problem. The position of a particle is given by s of t equals t cubed minus 6t squared plus 9t plus 2. Find the equation of the tangent line to s of t at t equals 2. Now let us work through the solution step by step. To write the equation of a tangent line, we need two ingredients: the point on the curve at t equals 2 and the slope of the curve at that same point, which comes from the derivative. We plug t equals 2 into the position function. 2 cubed is 8, 6 times 4 is 24, 9 times 2 is 18 plus 2. Adding those up, 8 minus 24 plus 18 plus 2 equals 4. The point on the curve is 2, 4. Now we differentiate the position function. The derivative of t cubed is 3t squared. The derivative of negative 6t squared is negative 12t. The derivative of 9t is 9, and the constant 2 vanishes. So s prime of t equals 3t squared minus 12t plus 9. Plugging t equals 2 into the derivative, 3 times 4 is 12 minus 24 plus 9. That gives 12 minus 24 plus 9 equals negative 3. So the slope of the tangent line is negative 3. We use point-slope form. S minus 4 equals negative 3 times the quantity t minus 2. Distributing gives s minus 4 equals negative 3t plus 6. Adding 4 to both sides, the tangent line is s equals negative 3t plus 10. Here we can see the tangent line with slope negative 3 touching the curve at the point 2, 4. The tangent line crosses the vertical axis at 10 and decreases as t increases. To verify, we substitute t equals 2 into the tangent line. Negative 3 times 2 plus 10 equals 4, which matches the point on the curve, and the slope is negative 3, matching the derivative. Both conditions check out. The tangent line is s equals negative 3t plus 10. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.